Hey guys, it's Mrs. Cavalier here, and we have been talking about transformations. We have focused on your warm-up on congruency, which is rotations, translations, and reflections. Those keep things congruent. That means it's the same shape and the same size. Today we're going to look at similar figures, and so we're going to focus on dilations. So, if a shape is similar, we can take, so we've been writing those congruency statements with our angles. We can also look at side lengths. What's specific about similar figures is those side lengths form a fraction, they form a ratio. If two things are similar, all of these fractions are equal. So they would all be 1/2, or they would all be 2. If one of them, just one of them is off, so maybe these two, say, are equal to 2, but this guy is equal to 3, then that makes our shapes not similar. So we're going to do a couple examples. So we're going to determine if these are similar by using the ratios of the side lengths, and then if they are, we will discuss the transformations that occurred. So if we look here, it does not matter where we start. It doesn't say if this is the pre-image and this is the image, so we're just going to pick a side and start with it. So this side is 3, this side is 1, 2, 3, 4, 5, 6, and notice I'm just counting the boxes of the side lengths. So 3, 6. So now this side is 1, 2, 3, 4, and this side is 1, 2, 3, 4, 5, 6, 7, 8. Since 3 6 is equal to 4/8, which is 1/2, these are similar. We could do this side, but those diagonals are hard to count, so we're just going to stick with these ones for now. So these are similar. The transformations that occurred, it looks like maybe there was a translation because it just was slid over, and then there was a dilation because they're similar. We could be more specific and say there's a dilation with a scale factor of 1/2 based on the way we wrote it. Now, if we would have started with the big shape, the big triangle, and done 6/3, 8/4, that would have changed our scale factor to be 2/1 or just 2. So as we work through these, if you have different answer than someone, as long as it's just the reciprocal, so this guy flipped 2/1 or 2, then you're okay. If you have something completely different, then one of you has made a mistake. Looking at another example, same thing, we have two triangles. Let's just start with the big one this time, doesn't matter. 1, 2, 3, 4 over 1, 2, 3. And notice I'm going with corresponding sides. I'm taking the heights. So 4/3. Now I'll do the bases, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4. So 6/4. Well, 6/4 reduces to 2/3. Does 4/3 equal 2/3? No. So these are not equal, so those are not similar triangles. So there's no transformation that occurred to make them similar because they're not similar. So even though this looks like it was reflected, the dilation was not consistent, so they're not the same. Okay, next example. We have two rectangles this time. So technically we should take all the sides, but since these two are equal and those two are equal, we just can look at the two sides and the relationship. So this side corresponds with this side, so that's 3/4, or 4/3 if I would have gone the other way. And then 1, 2, 3, 4, 5, to 1, 2, 3, 4, 5, 6, 7. 5 7s. Does 3/4 equal 5 7s? Not, I don't think so. Okay, I can't make it equal, so these are not similar. So there's no transformation. Yes, this was rotated, but the dilation was not the same, So it's not similar. There's two rectangles there, but they're not similar by definition. Definition of similar means they increase by the same amount, and they did not. The sides did not. So a different kind of example now. We have Ken, and he has a photo, and he is going to enlarge it by a scale factor of 2. And then once he enlarges it by a scale factor of 2, he's going to enlarge it by a scale factor of 1.5. The original photo is 2 inches by 3 inches. So 2 inches by 3 inches. So are the enlarged photos similar? And what's the dimensions? What are the dimensions of the new print? So the first thing he did was he doubled it. So he took this and he multiplied it all by 2 because he doubled it. So if I double it, that gives me a 4 inch by 6, whoops, not 16, 6 inch photo. Then he needed to increase it by 1.5 for his web page. So I'm going to multiply everything by 1.5. So that should be 6 inches, and that should be 9 inches. So this is the final dimensions on his website, the picture 6 inches by 9 inches. So that's this first question. And then it says, are the enlarged photos similar? Again, practicing our Hawks 5 non-negotiables. This is a word problem we're going to write in a complete sentence. So the enlarged photos are similar because we increased all the sides. Whoops, I forgot. We increased, hopefully yours looks nicer than mine, all the sides by the same scale factor. Okay, so we would write a complete sentence. So on the back of your worksheet that we're going to do in a minute, there are 2 word problems just like this. I expect to see 2 complete sentences. One more example like this. We have a baker who he has a photo and he is going to reduce that. He has an 8 by 10 photo and he is reducing it. He's first going to reduce it by 0.8, then it's still too big, so then he's going to reduce it by 0.9. So we got to figure out the final dimensions and figure out if they're similar. So we have our 8 by 10. We are first going to reduce it by 0.08, so I'm going to multiply by 0.8. So that gives me a 6.4 by 80, just 8, excuse me, 6.4 by 8 inch photo. Then we're going to reduce it again by 0.9, so multiplying by 0.9, and I'm going to use a calculator for that. And you're welcome to use your phone or calculator as well. And then 8 times 0.9 would be 7.2. So this is the final dimensions of our photo. So we started with the 8 by 10, and then on the cake it's now 5.76 by 7.2. And then I don't have room because Kanye's beautiful face is in our way. Just kidding. And so we would write a complete sentence that the reduced image is similar to the original image because we reduced all the sides by the same scale factor. Okay, so now you have your paper that you was passed out earlier that looks just like this. So we're doing the same kind of thing. There's no word problems. We're just figuring out if the objects are similar. So again, it doesn't say if you start with the big triangle to the small triangle. It doesn't say, so just pick a side. So that side's 3 by 1, 2, 3, 4, 5, 6. So 3 over 6. And then 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, is 3/6 equal to 4/10? No, so this is not similar. Okay, this one hopefully you can look and see just by looking at it that it's not similar, but we'll prove it with the math. So 1 to 1, so that side's 1 over 1. Then this side is 1, 2, 3, 4, 5. Well, there's no way this is 5. That's 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 over 1 does not equal 5/10, so those are not similar. 3 and 4. This side is 3, over, and this one's hard to tell. It looks like this was rotated here, so this would be my corresponding side. 1, 2, 3, 4, 5, 6. And then this base matches this, so that's 4 over 1, 2, 3, 4, 5, 6, 7, 8. So 3/6 is equal to 4/8, which is 1/2. So these are similar. Okay, then we have to describe the transformations because they are similar. Looks like we had a rotation. You could maybe say translation, maybe it was slid, but it was definitely rotated, and we had a dilation with a scale factor of 1/2. Or if I would have done it the other way, our scale factor would have been 2. Both of those answers are acceptable because the directions were unclear. Last one. This side here is 3. Corresponding side is 5. So 3 over 5. This side is 1, 2, 3, 4, 5, 6. And this side is 1, 2, 3, 4, 5, 6, 9. 3/5 does not equal 6/9. So these are not similar. Okay, so it's going to give you about, 10-15 minutes to do the back side of the page. Use this as an example. The sub does have an answer key. Number 1 is kind of a bad question, so just do the best that you can. On all of this, do the best that you can. If you're confused, we'll go over it on Thursday before we move on. So don't stress. Just do the best you can, check your answers, and turn it in. Thanks.